Hey everybody, welcome to our final review for this segment of Office Hours, as hopefully many of you are preparing for the next SAT, and this is kind of like your final prep for it. So let's start with our challenge problems for the week. So this first one, we got a function, all right? It wants the product of f of 2a with f of 18a. So let's remember a function has input and output. And whatever is in the input is what we are going to replace x with, and then evaluating that gives us our output. So f of 2a is really 2a over a minus 9. And then times f of 18a is going back to that same x and replacing x with 18a. So 18a over a minus 9. So these are nines. And we want that to equal 9 over 100. Now, trying to solve this is going to be a real pain. So what I'm going to say is to use Desmos. You have several ways to use Desmos. You could just put the whole thing in, but the answer is a decimal. Also, I'm going to use X's instead of A's. Um, and a lot of times when I do it, it just gives you a vertical line. And if it is a decimal, we're going to have to round this to, at the very least, three decimal places. I think that's I don't know if it will always do that for us. It typically works well when the vertical line is just like an integer, or maybe like something like a 0.5. But I don't think in this one it'll give us that level of accuracy. Um, I could also put the left side and the right side in and look for the intersection. But again, 9 over 100 is a really, really small number. So I really don't want to have to look for that horizontal line. So the other option is to just bring everything to one side, set it equal to 0, and look for the x-intercept. Also, it says a is a positive number. All right. So I'm going to go to Desmos. So let me go to that. And in Desmos, what I'm going to do is first change my A's to X's. So I'm going to have 2x over x minus 9. All right. Then times, now 18x divided by x minus 9. And then instead of equals 9 over 100, I'm going to subtract 9 over 100. And that gives me a function where now, since I brought it in one side, it's equal to 0. So what I want to do is I want to find where its x-intercept is, and that's right here. All right, so if I use 5 characters, I'm going to use 0.429. So let's remember that, 0.429. And that is it. That's our answer. So A would equal 0.429. All right. So just again to recap, these are A's and this is a 9. I know they look similar, but just kind of look at the problem. When I substitute in, when I multiply these together to give me 9 over 100, I chose to put it in Desmos where I brought this to the left side so that it was equal to 0 and looked for the positive x-intercept. 5 characters is 0.429. You could have also done, um, I guess, 0.428. I believe it was 7. Yeah, no, it was 0.4286. So 0.4286 if you chose to not put the 0 here. So that would have also been 5 characters. All right, let's move on to the next challenge problem. And let me try to make this a little smaller. There we go. All right. So in number 2, what we have here is I want to find the length of BC. So BC is this whole length. So what I'm going to do first is try to find CD. I'm just going to call that X. And when we have this kind of setup where we have two right triangles inside of a big third right triangle, they're all going to be similar to each other. And we're going to use ratios. So if I look at this small triangle and I do 5 over 12, what that represents is the short leg over the long leg. So now when I jump over to the medium-sized triangle, the short leg is now the 12 and the long leg is the x. So that's how I'm going to set that up. And then I'm going to cross multiply and I'm going to get 5x equals 144. So x is 144 over 5. And then it wants the length of BC. Well, BC, I would just have to add 5 to this. And 5 is 25 over 5. So you could definitely use a calculator here, but you want to get a little fancy with it. You just add 25 over 5 and you get 169 over 5, which is 33.8. So again, I would just use a calculator there to figure out at any point. The 144 over 5, you would have got 28.8, and then you add 5 and you get 33.8. All right, let's now move on to our actual review problem. So again, I tried here to go through and pick out the 12 most important problems to review the most important concepts ahead of a digital SAT. So here, in the given systems of equations, A is a constant. The graphs intersect at exactly 1 point. What's the value of x? So we want the value of x for which they would intersect at exactly 1 point. This is pretty tricky. I'm going to use Desmos here. All right. So I'm going to go into Desmos. I'm going to put this in. I am going to use the slider to get them to intersect at 1 point, and then I'm going to look for the x value. There is another way to do this, but this is the way that I'm going to try to do this. All right. Um, so, whoops. All right, so I'm going to put in the first one. So y equals 2x squared minus 21x plus 64. And then y equals 3x plus a. Put it back here. And I am going to add a slider. And I am going to do this. Okay, so the goal is to move this, right, so that I get it to intersect 1 point. So it looks like I have it there. And then when it does, the intersection is at 610. Here, let me zoom in a little more. Yeah. So this is tricky because -8 is one of the answers, right? But they wanted the value of x, not the value of a. This one is really tricky, all right? So it's the value when a is -8, that gets there to be one intersection. And then that intersection, the value is 6. So let's go back here. And so the answer is 6. Notice -8 is an option. That is the value of A that would make there be one solution. But that is not the value of X. All right. The other way to do this is a little bit harder because I'd have to set these equal to each other and bring everything to one side. And then I'd have to use the discriminant and I'd have to set the discriminant equal to 0. I think that's more challenging in this problem. You definitely need to know the discriminant. But in this one, I felt Desmos was a nice, easy way. But again, we have to be careful that the value of A being -8, that we don't choose that answer. All right, let's move on to number 2. So here we got an exponential combined with a percentage problem. So they want the number. So this is like our old a, b to the x, all right? And a is the initial value, b is the base or the number that we're multiplying by over and over again. In a percentage problem, it's going to represent the percent change, all right? So here, b, the number 1.2, is going to represent the percent change. And since it's bigger than 1, it means it's a percent increase. And 1.2 we can think of as 1.20. That is a 20% increase because let's remember you start with 100% always if you do nothing. And if you add 20% to that, that's going to give you 120%. And moving the decimal over twice is what's going to give you the 1.2. So it is the estimated number of customers is increased by 20% each year. All right, let's move on. So number 3, if x is an even integer, which of the following expresses z in terms of x? All right, so I'm going to just do this 2 different ways. So if you are confused at all about the algebra of this, then one way to do this is to just make, say, x equal to 1. And no, you know what? I'm not going to do 1. I'm going to stay away from 1 here. I'm going to choose 2. And so if I choose 2, if I plug in 2, I get 3 to the fourth plus 3 to the fourth plus 9 squared, which if you just do that real quick in a calculator, that is 243. That's what z equals. All right, so when I chose x to be 2, I want z to be 243. And then just start plugging that in. This is exponent of 5, 3 to the fifth is 243, but let's check the other ones. This is 3 to the sixth, which is wrong. This is 9 to the fourth, which is wrong. And this is 9 squared plus 27, which is wrong. So the answer is A. If you're looking for a more straightforward way and the more algebraic way, what you would do is you would do 3 to the 2x plus 3 to the 2x plus 9 to the x can be thought of as 3 to the 2x as well, because 3 squared is 9. And then if I have 3 of those, that's like 3 times 3 to the 2x. And then this is an exponent of 1. And when you multiply like bases, you add your exponents. So you get 3 to the 2x plus 1. So either way, we get 3 to the 2x plus 1, choose a value. The reason I actually didn't choose 1 is because 1 would have led to 2 answers being the same, um, namely A and B. Because if I plug in 1 here, I would get 3 and I would get 3 as well. So I'd get 3 cubed for both. So that's why I changed real quick and just made it 2. A lot of times you want to stay away from 0 and 1 when you're choosing your values. There are times to pick your spots where they could work out well for you. But in general, it's probably good advice to stay away from 0 and 1 when choosing your own values because they're kind of special numbers and they tend to have things, multiple answers might work out to be the same thing. Okay, let's move on to number 4. So number 4, we got a nice old equivalent expression. So what I'm going to do here is look for the value of BC. All right, so the way this one is going to work is I am going to end up realizing that in order to subtract these, I need a common denominator, and these don't have anything in common. So I'm going to have to multiply this one by 2x minus 3 over 2x minus 3, and this one over here by x minus 4 over x minus 4. And multiplying 2x minus 3 by x minus 4 does give me this. You could just double check, but it definitely does. So what I really care about is x squared times 2x minus 3 minus x minus 4 times x plus 12. I need that to be the ax cubed plus bx squared plus cx plus d. That's what I'm in search of. And the common denominator is going to eventually just cancel out on all of them. So now I distribute. So I get 2x cubed minus 3x squared. And then I'm going to do a quick FOIL up here. So this is x squared plus 12x minus 4x minus 48. And then this is going to become 8x. So then I'm going to distribute the negative. So I get minus x squared minus 8x plus 48. And finally, when I combine like terms, I am going to get 2x cubed minus 4x squared minus 8x plus 48. Now just match up. The value of b is going to be the coefficient of x squared, so that's going to be -4. And the value of c is going to be the coefficient of x, so that's going to be -8. And -4 times -8 is 32. And that is our answer. All right, moving on to number 5. All right, so for this one, we're looking for just kind of the understanding of how to change from rational exponents to radical form. So this 2 represents the power, and this 7 represents the root. So we're going to have the seventh root of 3 root a minus root b squared. Well, they're all seventh roots, so that doesn't really help me. I need to figure out what 3 root a minus root b squared is. Well, that's just 3 root a minus root b times 3 root a minus root b. And I'm going to do FOIL. So this ends up being 3 times 3 is 9. Root a times root a is a. So I get 9a. Let's remember it is the seventh root of all this. And then my outer is going to be minus 3. Root a times root b is root ab. And then again, I'm going to get another minus 3 root ab. And then minus root b times minus root b is plus b. And now I can see that I have minus 3, and minus 3 is going to give me minus 6. So the answer is D. Seventh root of 9a minus 6 root ab plus b. All right, now on to number 6. All right, here is one where one of the earlier ones I chose Desmos over the discriminant, but here is one where I'm definitely going to do the discriminant because this one is going to be a little more difficult to use Desmos. So A is a constant. We know that the equation has no real solutions if A is less than K. What is the greatest possible value of K? So what I'm going to do is just use the discriminant. All right. So hopefully we know if we do a quick review, the discriminant is the b squared minus 4ac. And what that represents is the expression that's under the square root in the quadratic formula. And that determines how many solutions there are, because if that is negative, then there's going to be no solutions because you can't square root a negative. All right. If it's 0, then there's one solution. If it's positive, then there's two solutions. So here we want no real solutions. So we are simply going to set our discriminant less than 0. Now, b in this case is 30. So 30 squared is 900. Minus 4a is a, and c is -9, and we want that to be less than 0. And then I get 900, and becomes plus 36a is less than 0. And then I get 36a is less than -900. Finally, divide by 36, and I get a is less than -25. So notice that K would have to be -25. Now, the wording is a little strange, but just kind of focus on the A is less than K part. But if they want the greatest possible value of K, so we want the equation to have no real solutions if this is true. So the reality is if K were any number greater than this, like, I don't know, -24, like that wouldn't be true because A has to be less than like -25 for there to be no solution. So if I pick a number greater than -25, it's just going to be false. Like if I do A is less than -24, then all the numbers between -24 and -25 would actually not make this have no real solution. All right. So the greatest possible value that we can put here to make this a true statement is -25. Right. So again, even that was probably confusing. The reality is, if you see this, try to just recreate that, which it naturally happens if you just do the discriminant and solve the inequality. And then the number over here is K. It just matches up perfectly. You do a lot of like matching up on this new digital SAT, making things look like what they want, and then just like matching things up and giving the value of the constant that's in that same position. All right. Moving on to number 7. The revenue of a small online business increases by 5% each year for the first 2 years and then by 3% each year after. The revenue is $20,000 in 2020. Which of the following estimates the revenue of the business in the year 2030? All right. So if in 2020 it was $20,000 and it's going to increase by 5%. So we have to know by now that a percent increase, 5% increase is multiplying by 1.05 for the first 2 years. So that's going to happen 2 times. And every time it happens, I'm going to multiply by it. So that repeated multiplication is where the exponent comes from. And then it's going to increase by 3% each year after that. That's 1.03. And so from 2020 to 2030 is 10 years. In the first 2 years, it does this. So this is going to happen another 8 years. And if you just throw that into the calculator, you will end up getting A, which is 27,932. All right. So we really just got to understand percent increase and how to represent 3% increase and 5% increase as a single numerical value. All right, let's take a look at number 8. So we are just comparing standard deviations. All right. Now, the standard deviation is just a measure of spread. So it's a measure of spread. Essentially, how spread out is the data. And it's really what's the average distance a data point is from the middle. So notice the frequencies are the same. So they're kind of spread out the same way, except A, the travel time minutes are much closer together. So the frequencies are the same, but B, the travel times are much further spread out. So you're going to have the same amount of values that are I guess this like a certain distance away, but the distances that all the values in B are going to be from the middle are going to be way bigger than all the distances from A. All right. So because of that, the standard deviation of B should be much larger, or in letter A here, the standard deviation for A is less than B. So that's it. You're just looking for which one has data that's more spread out, and that's going to have definitely a larger standard deviation. So going from 25 to 40 as opposed to 44 to 48 is going to give you a larger standard deviation. All right, let's move on to number 9. So we've got one of our statistical analysis problems here. So we selected a random sample of 15 sea lions. The marine biologist found that the mean mass was 480 pounds with a margin of error of 38, which is the best interpretation. So basically, first of all, what's really important is that one thing you can do is find the margin of error is kind of how far off we could be. So we could be at 38 in either direction. Problem is, if you do 480 minus 38 and 480 plus 38, you get 442 and 518, which every answer has. So this is a little bit of a harder problem. Some of the easier problems, you might only have one answer that has those numbers in it or two, and it would be a lot easier. But this one, we really have to understand what margin of error is. And if our deeper understanding is that we're doing this random sample, and it's important that where we took the random sample from. They went to La Jolla or La Jolla, I'm not sure exactly how to say that, and selected a random sample of 15 sea lions. All right. So wherever we selected the random sample from, then the we can kind of generalize that to a larger population. And since the larger population, it's not feasible to actually find the average. We can assume that it's between 442 and 518. That's like our best guess. So what we want to do is really focus on where we took it from, and it's from this place, I'll say La Jolla. And so all sea lions, well, no, we only took the 15 from this place, so it's not that one. Most sea lions have a mass between them. That's not at all what it's saying. And any mass between these two values is plausible. I like that word for the mean mass of any sea lion in that area. So that makes more sense. Now, any sea lion at La Jolla shores has a mass. That's not what it's saying. It's not saying that they're all between there. It's saying that the mean of this larger group of sea lions is likely. So the word plausible is good here. So it is going to be C. All right, number 10 is similar triangles or really just similar figures, and these ones have to do with scale factors. All right, so to review a scale factor, I always use the letter K for that. It's what we would multiply any single dimension by to go from a smaller figure to a bigger figure, or just one figure to another. Doesn't always have to be smaller to bigger. And that is what we call our scale factor. And then anytime we want to find anything out about, let's say, the area, you would always multiply by the scale factor squared. And if you wanted to do volume, which doesn't apply to this problem, but you would do scale factor cubed. So when they say the area of 16 times the area, that means our scale factor squared is 16, which means our scale factor is 4, because k would be 4 in order for k squared to be 16. So if the length of side AB is 68, now it's really important. ABC is 16 times. So triangle ABC is bigger than triangle XYZ. So if our scale factor is 4 and the one side is 68, that means that the smaller side got multiplied by 4 to get you to 68. So to actually get our answer, we want to do 68 divided by 4, which is 17. So the side length, the single dimension, would have to have been 17. And we don't need k cubed here. I just wanted to, again, talk about that concept. All right, on to number 11. So triangle JKL is similar to triangle RST. Okay, and they tell us what corresponds. So since they give me the relationship of L, which is triangle JKL, I am going to draw that triangle. You do not need to draw both triangles for this. All right. Um, whoops. So let's say that's our right angle and J. Okay, angles K and S. So K is the right angle. That's what I really care about. And then I just put J and L like this. Okay. So the cosine of L. Let's recall that if L is our angle, then this is the adjacent side, this is the opposite side, and this is the hypotenuse. And cosine, so TOA, relates the adjacent and the hypotenuse. That means this is 119 and this is 169. Now, I could find the other side using the Pythagorean theorem, but if I look at every answer, the only other number in the problem is 120, so it's safe to say that this would need to be 120. All right, so that's another way we can just use our answers to save a little bit of time, but it wouldn't take too long if you want to double check that using the Pythagorean theorem. Now, here's the really important part. Don't worry about the similar triangle. If they want us to find the tan of t, just know that t is the last letter and t goes with L. All right. So asking for the tan of t is the same as asking for the tan of L. And let's remember tangent is TOA. That's the opposite over the adjacent. So that's 120 over 119, which is letter C. All right. So in these similar triangle problems where they're testing trig, I very rarely see one where you need both triangles. Even if they told you what the scale factor was, just ignore it. The way it works is like anything that they ask with the letter T is going to be true of the letter L. Same thing with R and J. S and K would be the right angle, so that wouldn't really make sense. So again, it's a ratio, so the ratio won't change. The actual side lengths would change, but the ratio won't. All right. So just ignore the fact that they asked for T and just do it for L. All right. And then we have to go over in any review a equation of a circle. All right. And the equation of a circle is x minus h squared plus y minus k squared is equal to r squared. So to get this to look like that, I am going to complete the square twice. And I think what I'm going to do is, just because we have access to calculators, I'm just going to make this 38.5, and I'm just going to do this in decimals. All right. So the way that we complete the square is we add half of b squared. Well, b is negative 1. Half of negative 1 is negative 0.5, and negative 0.5 squared is 0.25. If I add 0.25 here, I got to add 0.25 here. And then I'm going to take half of 13. So 13 divided by 2 is 6.5. And I'm going to square it, and I'm going to get 42.25. So I'm going to add that. Now, in this problem, all I care about is the diameter. So then I only need the radius. So I only care about the right side of the problem. So if I do 42.25 plus 0.25 plus 38.5, my right side of the problem is 81. So r squared is 81. So r is 9, which would mean the diameter would have to be 18, and that's the answer. I don't really care about the left side, but just to go over it, this would be x minus 0.5 squared, and then this would be y plus 6.5 squared. And the center would be zero point 0.5 comma negative 6.5. But again, they didn't ask that, so I wouldn't have done any of that on the actual SAT. If you are asked for the center, a center related question, then you focus on the left side, what happens with these factors. If you are asked for the radius or the diameter, focus on the right side. Either way, you need to know what values you're adding to complete the square. But once you know those values, focus on the right side when it's a radius diameter problem. And also realize you could use Desmos. If you plug this into Desmos, there is ways to figure out um like like you would have a circle, and what you would do is you would just try to figure out this coordinate and this coordinate and just like subtract the x coordinates to find out like what this distance is. Or you would find this coordinate and this coordinate, bottom and top, and subtract the y values to get that distance, which is the diameter. She definitely could use Desmos here. I just felt that if the reality is, if you just take the 38.5 and add the two completing the square values, you can get to 81 pretty quickly. Okay. All right. Thank you for attending or watching. Check us out on TikTok or other YouTube videos. We also offer one-on-one tutoring. We'll be having courses, call, text, email. Or if not, then don't worry about it. Just keep looking out for more and more content. We'll keep having the office hour on Monday nights at 6 o'clock, and I will keep posting content just to continue to help prep for the SAT all year round. All right. So thank you.